Hello everyone, I'm Fazi and I'm at Beifang Education. As we know, electric vehicles are developing really fast. So today we will talk about what kind of batteries do electric vehicles requires. As we know, the power source of electric vehicles are the high voltage batteries. So let's talk about some main points that we require our battery to accomplish. So by using a teaching material that is a Geely EV450 vehicle battery, we will try to understand the structure and functioning of the battery. So if we talk about the first point is the energy density should be high. What is energy density? Energy density is simply the battery storage capacity. So we hope our battery to have the large battery storage capacity so that we can have the more and increased range to our cars. The second point is about the charging time. We hope that our batteries should be charged more fastly in less time. So less time required to charge the battery, the more better for us. The third point, if we talk about the third point, that's the temperature. I think the temperature variant is really important because no matter the temperature is below the zero or above the zero, we are at the mountains, we are at the plains, at high altitude or at the low altitude, the battery must be functioning properly. So if we talk about the next point, then we hope a battery have the fast discharge response speed. The discharge response speed also matters a lot. We want the discharge response speed to be as fast as corresponding to the signal of the gas pedal. And then the last point is the security. Obviously, security comes first. So for the batteries, I think the security is the main factor. Regardless of the other parameters of the battery, security must be really good and it must be tightened. So if we talk about the security, we maybe have different conditions like a bump, a collision, an explosion. So we want our battery to work normally and in a good condition. No matter it's a bump or it's a collision, the battery should not explode or it should not catch the fire. So these are the some main points that we require our battery to achieve. So nowadays in the electric vehicle field, we adopt these three kind of batteries. So here in the graph we can see the three different kind of batteries, their advantages and their disadvantages. So if we talk about our first kind of battery, that is NiMH battery, we see that the battery adopts a low cost, but the energy density of the battery is not quite high. It's just from 60 to 80 kilowatt hours. But having the low energy density, it has some advantages. That is its performance in the low temperature. Even in minus 20 degrees, the battery adopts almost more than 80% of the battery capacity. So we can see the battery temperature adaptation is really good. It is highly safe, but the problem is the rated voltage is just 1.2 volts. So if we see the second type of battery, that is lithium iron phosphate battery, then we can see like the battery is low cost, the temperature variation of this battery, it's working good in the high temperature, it has good resistance, temperature resistance, but in low temperatures like minus 20, the battery do not adopt the good capacity. It's just the capacity reduces just to 50 to 55%. And the thing is, like if we talk about the energy density, then we can see the energy density is average. It's from 100 to 150 kilowatt hours. Again, the battery is safe and the rated voltage is 3.2 volts. So if we talk about the last and the third kind of battery, that is ternary lithium battery, then we see It costs high, but the energy density of this kind of battery, it's from 200 to 300 kilowatt hours. That's quite good. But again, then comes the temperature factor. And if we talk about the temperature factor, we see this battery has poor resistance, the poor heat resistance. That means in the higher temperature, the battery performance is not quite good. But in the low temperatures, the battery capacity is good. So here we see the battery is high costly, but the rated voltage is 3.2 volts. So here was a brief description about the advantages and disadvantages of the three type of batteries. So here our equipment adopts a Geely EV450 ternary lithium battery. So let's talk about another problem. Why electric vehicles require high voltage batteries? The answer to this question is, as we know, power is equal to voltage into current, as voltage and current are directly proportional. So if we use less voltage batteries, then we need to increase the current. And what that means, if we increase the current of the battery, then the corresponding wire should be more thick, and the electric coils in the motor, they should be more big. That's more inappropriate for the installation in the electric vehicles. So that's why we use high voltage, and when we use high voltage, that means that we use the less current. And when we are using the less current or low current, then the corresponding wire thickness will be low, and the size of the motor, it will be more small. So it's not too much costly, and it looks appropriate when we are setting the material in the cars. So if we talk about our battery, here we can see we have 7 modules, and each module is having some single cells. So here I have a ternary lithium battery. So we have this kind of single cells in one module. This one is a whole module. So when we are talking about the modules, two single cells like this, they are connected parallel to increase the capacity. But when we talk about the module, then in the module we have 5 pack of cells, and they are connected in the series to add the voltage. So why they are connected in the series? To boost the voltage, and we need to add the voltage. So here we can see the 7 modules. These 7 modules are in the front part of the car. So until there we have the 7 modules, and if we talk about the rest of the 10 modules, they are in the rear part of the car. So what's the difference between these 7 modules and these 10 modules? We can see the layer of modules, like that is 1, 2, 3, 4, 5, and another layer below this. There are total 10 modules in the rear part of the car. So if we talk about these modules, we see they are bigger as compared to these 7 modules. Why they are big? Because we have 6 pack of cells in each module. So if we talk about the voltage of each module of this front part of the car, these 7 modules, then using the voltmeter, we can check the voltage of each ternary lithium cell. We can use this voltmeter to check the voltage of this real battery, the total voltage of this real battery. So here we can have a look about the voltage. So we can use a voltmeter to check the voltage of the real battery. So if we check the positive and negative terminals, we can see the voltmeter giving the value of voltage. So here, by using voltmeter, we can see the voltage of each pack of the battery. So now if we check the total voltage, then we have a value of 18.5. This voltage is a little bit high. It's just because there is no load right now. So if we talk about this part, we have 6 pack of cells and the total voltage of these modules is 18.2. But as we are using the 6 cells in here, so the total voltage of these 10 modules, each module should be 21.8. So let's have a review about these 17 modules, how they are connected, which one is the first module, from where we will get the positive terminal and where is the negative terminal. So here we can see we have a very first module that is just here, and it's also responsible for the negative terminal. The short wire we can see here is the negative terminal. Then we can see our second module. Then comes the third one, the fourth, the fifth, and up till until we reach to the 17th module. When we reach the 17th module, we see that all these modules, they are connected in series, and the total positive output terminal is on the 17th module. We can see a wire over here, that is our positive terminal, and on the first module, as I already talked, we have a negative terminal. So these are connected to this control box, and I would like to tell that it's not safe to touch them without the safety gloves, or if you are under the supervision of your teachers or any professional, then you can touch it and then you can use it. Otherwise, it's not safe to use it. So here we can see, then we have some parts like a resistor, the connectors that are responsible to prevent the battery from explosion and to prevent the battery from getting heat or getting extra voltage. So the total voltage of the batteries, total voltage of these, all the 17 modules, and the 17 module consists of a battery pack. So how much is the total voltage of this all battery pack? We can calculate it by using 3.6 multiplied by 7 and then 21.8 multiplied by 10, and we will get the total voltage of the battery pack is 346 volts. So if we talk about the data of the battery pack, as I already told, the total voltage is 346 volts. And the electricity, we also call the degree of electricity, it's 53 kilowatt hours. So let's talk about the electricity consumption. If we say 12 kilowatt hours is enough for 100 kilometers, then we can calculate the total mileage by using, we can divide 53 by 12 and then multiplying by 100, we will get a value that is almost roughly 430 kilometers. So we have another important parameter, that is SOC value. So SOC value is like how much total battery we are left with. It's same as we use in our mobiles, like how much battery we have left. So it's same within the car, that how much battery we are left with. So in this lesson we will not go further about the SOC value. We will talk about this in our next lesson. So for more exciting lesson, please stay tuned on the Beifeng Education.